Okay. Good evening. Good afternoon. Welcome you. Look at this is what is called this one. What is
Mass spectrum.
mass spectrum? Okay. This mass spectrum. You know this mass spectrometry, like geometry. Here is a mass spectrometry is a branch of science. Mass spectrometry is an analytical technique that measure the mass to charge ratio of ions. The results are typically presented as a mass spectrum. A plot of intensity is function of the mass to charge ratio. Okay, this is the mass to charge ratio. This is mass to charge ratio. This is the relative abundance. Abundance is 100%. Like this. Here this abundance 100%. Okay, this is the mass to charge ratio. Mass to charge ratio is on the x axis and relative abundance on the y axis. How do we find the mass to charge ratio? Mass to charge ratio means in a mass spectrum, chlorine ions. You know what do we do this mass spectrum? Isotopes. At first, in a mass spectrum, we
Sir, your voice is not clear.
huh? Uh,
Your voice clear flash, sir.
Not clear. Is it now? Is it clear now?
Yes, sir.
Okay. This is this one is chlorine. Chlorine. We know this. What happened in the mass spectrum? Mass spectrometry. Mass spectrometry here. This in here. Here we enter sample. Sample. Sample need the gaseous state. Sample must be in the gaseous state, so we vaporize this gas, and then are you watching my screen? Hello, student. Here we inject sample. Where's my cursor? Here we inject sample. Okay, sample inject, and here sample must be vaporized. So we vaporize sample, then electron beam. We bombard with electron, then this samples vaporized samples atoms becomes ions. One electron loss and becomes ions. Then the ions accelerated, where we accelerate the ions. Accelerate these ions, and here the magnetic field. Magnetic field deflect the ions according to their mass to charge ratio. If the mass to charge ratio is low, less deflect, most deflect, and more mass to charge ratio, less deflect. This is the less deflect, and this is most reflect, because less mass. It is inverse proportional. Inverse proportional. If mass to charge ratio is more, less deflect. It's less mass to charge ratio, more deflect. Okay, then is detector detect the mass to charge ratio. Okay, this is the mass to charge ratio sample. What is mass to charge ratio? What do you mean by? Like this is ions. This is the charge ions. This is charge ions. Okay. What is mass? This sample. This is the chlorine 35 sample. We know what is the mass. This one. Mass. Chlorine 37. What is the mass? This chlorine 37, 35. Hello. What is mass? This is the mass 35. Okay. Mass to charge ratio is m divided by z. Okay. So what is the mass? This one. This sample is a mass is 35, and charge is one charge, so divided by 1, so total is 35. So mass to charge ratio is 35. Okay. This simple, what is the mass to charge ratio? Mass is to, what is the mass to charge ratio? 37 divided by 1, that is 37. Okay, which one will more deflect, chlorine 35 or chlorine 37? Deflect. Hello, which ions will more deflect, chlorine 35 isotope or chlorine 37 isotope? Oh. Okay, you may be missing something.
Yes, sir.
What happened?
Yes, sir, I cannot hear your voice.
Now are you listening?
Yes, sir.
Okay, what is the mass to charge ratio? This chlorine 35 and chlorine 37, these two isotope. Okay, which one has this the mass? 50 m divided by z. M is mass, z is the ion charge. The charge is one charge. So what is the mass to charge ratio? 35. This one is 37. Have you understood? Okay. This is the mass to charge ratio. These ions. This one. This the ions deflect in the magnetic field depend on the mass to charge ratio. It is inverse proportional. If the less mass to charge ratio, more deflect. The mass to charge ratio is more, less deflect. Less mass to charge ratio, more deflect. So which one will more deflect, 35 or 37?
35.
35, because it is light, so more deflect. So here deflect. Okay, next things is, okay, this is how does mass spectrometer work? How does mass spectrometer work? You know this thing already. At first here, 1, in the 1 position, here we enter sample, and it is this sample is vaporized in high temperature region. In the region 1, here in 1 position, sample is injected and it is a high temperature region. So it is, as a result, the sample is vaporized. Okay, so gaseous state become gaseous state. Sample must be turned into gaseous state. For regions we vaporize it in a high temperature region. Then in that region 2, here is the electron beam. Here in a electron bombardment with electrons, this charge, this gaseous atom becomes one electron loss electron and become positive ions. Okay, and this in the 3 electric field. Due to the electric field, this electric field accelerate the ions, move faster, and here then accelerate the ions. Here the magnetic field. In the magnetic field, these ions, due to the magnetic field, these ions deflect according to mass to charge ratio. More it is inversely deflected. Inversely, if mass to charge ratio is less, more deflected. If more mass to charge ratio is less, more deflected. Okay, this one is light particle more deflected, less heavier particles less deflected. This is mass to charge ratio is less. This the light mass to charge ratio is more, so less deflected. This one is mass to charge ratio is more, mass to charge ratio is less, so more deflected. Oh, sorry কি বলতেছে? Mass to charge ratio is less, so more deflected. Okay, then ions detectors. Here's ions detectors detect the ions. Here is given the mass spectrometer measures the positive ions formed from the atoms. Mass spectrometer works in 5 stages. In the first step, sample is vaporized in a high temperature region. Electron second step, electron beam ionize atoms in vaporized sample. The vapor is ionized by bombardment with high energy electrons. Electrons are knocked out of the atoms. Knocked out means out from atoms. At the result, it becomes positive ions, and the positive ions are accelerated by an electric field. And 4 is then the ions have their velocities equalized by velocity selector. Then ions are deflected by magnetic field. The amount of deflection depends on the mass to charge ratio of the ions. Ions with a large mass to charge ratio are deflected less than ions with a small mass to charge ratio. If the ions have the same charge, usually +1, the extent of the deflection is inversely proportional to their mass. Deflected ions are recorded by detector. Okay, draw a mass spectrometer. Okay, you can draw. I will not teach more. You will be able. This is was class work, but I will not do this one. I will give this one homework. Homework. Okay, don't need to time already kill. Gone. This one. Answer is this one. You will draw this one. Okay. Drawing these things and mark also. This is the magnetic field and ion detector, electron beam, vaporized samples. This you will write this. Okay. Next question is here. This is the what is this? This is the mass spectrum of what is this? Mass spectrum of chlorine. Okay, okay, chlorine. Look at this is the there is a peak here in at 35 and here is the 37. This 70, 74 and 72 and 74 here peaks mass to charge ratio. This is the relative abundance. There is no relative abundance given. It is do you know how much relative abundance? 90, 14, 100, 100. Relative total is 100. Question A is what are the relative masses of the two isotopes present in the chlorine atom? This is the two isotopes here, chlorine atoms. Question is what are the relative masses of the two isotopes? Look, two isotopes. Chlorine has two isotopes. Do you know the what is the relative isotopes of the two chlorine atoms? How do you know how many isotopes of chlorine? Do you know how many chlorine have how many isotopes? Chlorine has two isotopes, chlorine 35 and chlorine 37. So there is a what are the relative masses of the two isotopes? This is the 35. This one is
37.
good. 35 and 37. Okay, this is two isotope 35 and 37. Okay, this way charge become this chlorine 35 chlorine, this is the 35. Hey, mass to charge ratio is 35 for chlorine 37. This is the 37. Okay, when chlorine atoms ions, this chlorine two chlorine atoms like 235 chlorine atoms joins, so then what will be mass to charge ratio? What will be mass to charge ratio when two chlorine 35 joined? 35, this 2 is 35, it will be 70. 70, charge is 1, so 70.
70.
when 2 chlorine 37, no, 1 chlorine 35 and 37 joint. So what will be mass to charge ratio? 35 and 37 joint. What will be mass to charge ratio is 72. Okay, 72. And when 237 joint, 237 joint, then 74. Have you understood? I am writing here 37 divided by 1, that means 74. Okay, this is the mass to charge ratio: 70, 72, 74, 35 and 37. This is the possibility for formation of ions. So which ions will more deflect? This one, this one, this one, this one, or this one?
35.
This at the top one, no?
Yes, sir.
Okay. Okay, so what are the two isotope relative masses of the two isotope? Question number A answer. A answer is A answer is, what is answer A? Question number A. I'll take another class on Saturday. Have you any problem? Saturday?
No, sir.
Saturday, okay. Today's class I'll finish quickly. Saturday I'll take 11 o'clock, okay. A, because we have something many days we are not taking classes. So answer is 35 and 37. Okay, now question number answer B. B answer. Now what is the question B? Okay, identify the particles responsible for the peaks at mass to charge ratio. This is the mass to charge ratio: 70, 72 and 74. Which particles are responsible for this mass to charge ratio for 70, 72 and 74? Okay, for 70, which one? Which particle is responsible for 70? For 70, chlorine, both chlorine 35, both 35, 235 chlorine here. This particle is responsible for 70. Okay, now 72, which particles is responsible? 72, chlorine 35 or chlorine 37?
35 and 37.
Yes, both. Chlorine 35 and chlorine 37. This one must to give charge here, one charge. Okay, and for 74,
Chlorine 37.
both one is 37. Both two.
Yes.
72, both one is 37. Okay, this is the question to finish. B finish. Okay, now I go to C. Question number C. C is deduce the relative abundance of two isotopes and explain the weight of three peaks at mass to charge ratio 70, 72 and 74. So what will be relative abundance of the two isotopes, and pick and explain the weight of the three peaks at this one, and deduce the relative abundance of the two isotopes. Okay, what will be the relative abundance of the two isotopes, like this 35 and 37? What is the ratio? Look at this one and this one. 37 this one and 35 is this one. So is this one is 1, 2, 3. So what is the ratio here? Do you know? Here, look at the picture quickly. Are you watching this picture? What is the ratio?
Yes, sir, I'm watching.
37 is 1, and this is the how parts? 3 times. 3 times is higher.
3:1.
So what is the ratio? Is 3 is to
1.
3 is to 1. So the relative abundance of the two isotope is, this is the 3 is to 1, that means 75, and this one is what? It total is 100. So it will be 35 will be
75.
okay, this it will be 25. Okay, so the answer is relative abundance of the two isotope is 75 and 25, or this thing, or 3 is to 2. So I am writing answer. On the two isotopes is 75 is to 25, or 3 is to 1. Okay, this is 3 is to 1 as the height of the. Okay, this, have you understood this one? Okay, next.
Yes,
Okay,
sir.
peak. Next, this is the two portion, this question. Second portion is explain the weights of the three peaks. This is actually peak of the three peaks. This one, this 72, 70, 72 and 74. Okay, this is the 70. 70 is this 70 for 70. Okay, 70 which two particles, which two chlorine isotopes joined? 70 which two isotopes? 35 35 or 35 37 or 37 37? What 70? 2 is 35. So chance of two chlorine atoms, two 35 chlorine atoms together. This one is total is 4. Chlorine 35 is total chlorine 37 and 35 total is chlorine 35 is this 3 and 1. 3 is 35. 1 is for 37. If 237, what will be this? If total is 4, 3 and 4, and it is for this chance is for chlorine 35. another chlorine 35, 4 into 3. Okay, and if 37, it will be 4 is to what will be chlorine 37, what will be 40 1/4 for chlorine 37. Total is 4, and for combining chance for 35, 4 is to 3/4 for 35. 3/4 chance probability is chance combining 3/4 for chlorine 35, and 37 is 1/4. Have you understood this one?
Yes, sir.
Total is 4. So 3/4 is for 35 and 1/4 is for 37. If two join, two no, two particles, two isotope join, so what will be, I am writing here, chance of here 2 chlorine chlorine 2 chlorine 35. Okay, what will be 1/4 na 3/4? 3/4 into 3/4 for one atom, 3/4, another 3/4 into 3. Total is 9 16th. Okay, now we'll do the chance of 135 and 137 atoms combining together is. Okay, so I am writing here, chance of a chlorine 35 and chlorine, I should space something for chlorine 37 combining together is. Okay, this one is 35 and 37. Okay, so what will be for 35? 3/4. Okay, for 37 1/4. That means 3/16. Okay, here 3 by this one is another possibility is possible, another chlorine 37 here and 35 also, another possibility is here. I am writing here is another possibility, this chlorine 35 and 37. So same things will be 1/4 into 1/3/4, same things. For 35 and 37 it is possible 35 and 37 and 37 and 35. Okay, so it is same things. I can multiply. What I'll do, This is the same things. This is the 35 and 37, and it is 37 and 34. Sorry, 37 and 35. It is both are same. So what can I do? It is double. I give here which number I give.
3 by 3 4.
No, I give just same things. I give double. So I multiply 2. Have you understood? It is possibility is same things. Also, this is the 35 and 37 this way, and 37 this 35 and 37, 3 by 4 and 1 by 4, and again 37 and 35. This is same. 1 by 4 and 37. These are same. Same ultao same hoye jabe na. So I can do these things double. So I give here multiply 2. Okay, so this is 3 into 1 3 and 2 6 16. Okay, next things is next chance is chance of how which two chlorine atoms.
37.
37 2. I can copy paste this one. I can copy paste. Yes, copy paste is very easy. I'll write these things. Just I'll cut here this one. 37 237. But you must change what was this here will be 1 1, and also here 1. So we have found these things. Ratio we find. So look at here, all is this the below. It is called, I forget this one, this top and below. It are yes, yeah, I forgot this one. Here is a 16 is same all the below this. So I can eliminate it, nullify, banish these things. So I take this which things part, this top part. Okay, here is 6. This is 6 for which particles? 9 for 35 and 35 for 70. For 79. For 72 6. For 74 is 1. Okay, so that gives the ratio. This gives ratio of 9 is to 6 is to what?
1.
Good. For the peaks, it's corresponding to n mass to this one is mass to charge ratio. Of 70, 72 and 74. Okay, so we have found answer. Have you understood these things?
Yes, sir.
Okay, this question finished today. Thank you for joining today's class. Okay, now I am giving this homework here. Look, this is homework is here. Homework is this question. This question solving. Okay, same question. Now I have finished this one. Question number 5. One and question number 5, and draw the mass spectrometer. This draw mass spectrometer. Okay, thank you for joining today's class.
Thank you, sir.